We rely on science for, well, just about everything. It guides our health, our policies, our technology. We trust it to be objective, to be the truth. But what happens when that science has a sponsor? You know, when a corporation or a private foundation is footing the bill. Can we still trust the results? That's what we're going to dig into.
First off, let's just establish why this matters so much. We tend to put university research on a pedestal, and for good reason. We see these institutions as these pillars of independent thought, right? They're supposed to be pursuing knowledge just for the sake of it, totally free from outside influence. And that special position of trust, it's absolutely fundamental to how our society functions.
This quote really just nails it. The whole idea is that science should be a public good. But if that knowledge gets compromised even a little bit, the entire foundation starts to feel shaky. And that affects everything, from huge government policies all the way down to our own personal health decisions.
And here it is. This is the big question. It's where the ideal of pure, independent science crashes right into the messy reality of funding. Because let's be real, research, especially the big stuff at major universities, is incredibly expensive, and that money has to come from somewhere.
Okay, so let's follow the money. Where does it actually come from, and what kind of impact does it really have? You might be surprised. The scale of sponsored research is massive, and it's woven right into the fabric of modern academia.
Just so we're all on the same page, sponsored research is basically any investigation that's funded by an outside group. That could be a government agency like the NIH, a private corporation, or a nonprofit foundation. The key thing is, every sponsor has its own goals and interests.
Now, take a look at this. The government is still the biggest funder, sure, over half, but check out that industry slice. Over a quarter of all funding, and it's actually the fastest growing part of the pie. So this isn't some fringe thing, it is a core part of the research ecosystem today.
So what's the actual effect of all this industry money? Well, a huge systematic review from Cochrane, a real gold standard in analysis, found that studies sponsored by industry are 3.6 times more likely to come up with results that are favorable to the sponsor's product. Let that sink in for a second. 3.6 times. That is a staggering number that you just can't explain away by chance.
So, how does this happen? Is it just a bunch of scientists faking their data for a paycheck? Well, not usually. The reality is actually way more subtle and, in a lot of ways, more concerning. The bias isn't always some evil, overt thing. A lot of the time, it's built right into the system itself.
Yeah, outright fraud, just making up data, that's incredibly rare. And when it's discovered, it's a massive scandal. The much bigger, more common issue is what we call systemic bias. This is where you can subtly shape the design of a study to make a certain outcome more likely. You know, things like framing the research question in a particular way, or testing your drug against a really weak competitor. Or maybe you measure 20 different things but only report the one that looks good. It's about tilting the playing field, not cheating outright.
And this all leads to one of the biggest distortions in science: publication bias. Just imagine a sponsor funds 10 studies for their new drug. 9 of those studies show the drug does nothing, but one shows a small benefit. Guess which one gets published? Yep, just the positive one. The other 9 often just disappear into a file drawer somewhere, never to be seen again. And the result, the public published record gives this dangerously misleading picture of how well that drug actually works.
And look, this is not just a theoretical problem. The Vioxx scandal is a tragic, real-world example of this in action. The company's own studies had data on cardiovascular risks that, well, it was omitted. The drug got approved, it was prescribed to millions, and by the time the whole truth came out, it was linked to thousands of heart attacks and strokes. The fallout from that scandal was what really spurred massive reforms to try and stop this from ever happening again.
Which brings us to the good news. The scientific community has been working really hard to build a stronger shield against this kind of bias. You know, recognizing the problem's the first step. And for the last couple of decades, researchers have been developing a pretty powerful set of tools to safeguard objectivity.
Think of it like a multi-layered defense system. It's not just one magic bullet, but a whole package of reforms all working together. Things like forcing mandatory disclosure of who funded the work, requiring that the raw data be shared with other scientists, calling for independent statisticians to analyze the numbers, and, this one's huge, making researchers register their trials in advance.
Pre-registration is maybe one of the most powerful ideas to come out of all this. It's so simple, but it's brilliant. Before you even start collecting data, you have to publicly post your entire game plan, your hypothesis, your methods, exactly how you're going to analyze the results. It's like calling your shot in pool before you take it. It makes it almost impossible to move the goalposts or cherry-pick your findings later on, because your original plan is locked in for everyone to see.
So, did it work? Oh yeah. The numbers are pretty clear. After trial registration became a widespread requirement, the percentage of industry trials reporting positive, sponsor-friendly results dropped significantly. This simple act of transparency started to force a much more realistic picture of the science, stripping away some of that favorable spin. So where does all this leave us? Well, for one, it shows that the scientific process isn't static. It's always evolving and trying to correct itself. And it gives us, as people who read the news and try to make sense of the world, a much smarter way to evaluate the research we see every day. If there is one single thing to take away from this whole explainer, let it be this. Objectivity is not some magical property that scientists just have. It isn't automatic. It is earned. It's the outcome of a tough, rigorous process, a whole system of checks and balances designed specifically to minimize the impact of our all-too-human biases.
So the next time you see a headline about some amazing new study, you can be what I call a smart skeptic. You've got a toolkit now. Just ask these 4 simple questions. Who paid for it? Was the game plan published in advance? Can other scientists get their hands on the data? And did the sponsor have a say in how the numbers were crunched? The answers to those questions will tell you a whole lot about how much you can really trust the results.
Ultimately, this gets us to a new and, I think, much more powerful question. Instead of asking the simple and, frankly, almost unanswerable question, is this study biased, we should be asking, were the safeguards strong enough to protect it from bias? That little shift in perspective, well, that's the key to navigating the complex and truly fascinating world of modern science.